Hi, AP Calculus students. Welcome to section 5.4b, where the integral of e to the x is e to the x plus c. Or of course, the integral of e to the u, if you do a substitution, is e to the u plus c. That's really it. So we're just going to do some examples, right? On 5.4a, you did derivatives of e to the x. So now we're going to do integrals of e to the x. So here we go. Number 104. Let's see. The integral of e to the x. Making sure I write it correctly. E to the x, e to the x plus 1 squared dx. All right. I see a product and I see a inside function. So I think I need a u substitution here. And I think my u substitution is the inside function. So that would be e to the x plus 1 would be my u. My du would be e to the x dx. I see a perfect substitution. Let's do it. Here we go. Here is u squared. E to the x dx, I will replace with du. I know how to integrate this. I'm going to add 1 to the exponent and divide by the new exponent. And my final answer is u cubed over 3 plus c, where my u is e to the x plus 1. Ta-da! 108. On 108, the integral of e to the 2x over 1 plus e to the 2x dx. Let's see. I don't see an inside function, but I do see a quotient. I'm going to try to make my u the denominator. That would make my du. The derivative of 1 is 0. The derivative of e to the 2x is itself times the derivative of the inside function, dx. I don't see a constant of 2. I will divide by 2. I think I have a perfect substitution. Let's give it a try. I believe my denominator is u, and my e to the 2x dx is a 1/2 du. This I know how to integrate. It is 1/2 the natural log, the absolute value of u plus c, where my u is 1 plus e to the 2x, which is perfectly true, except for 1 plus e to the 2x is always positive. So we don't need the absolute value. There we go. All right, let's try 122 and 136. I'm going to do a little erasing. On 122, let's see, we're going to integrate 0 to the square root of 2x e the negative x squared over 2 dx. All right, I see a product. I see an inside function of negative x squared over 2. I'm going to try to make my u negative x squared over 2. See if it works for us. Our du would be a negative, and when I bring the 2 out front and multiply it, the 2's will cancel, and I'll get a negative x dx. I do not see a constant of a negative, so I will multiply both sides by a negative. I believe I have a perfect u substitution. So I am going to switch my lower x to a u and my upper x when I'm sure that I have a substitution I can do. This is going to be e to the u, and x dx will be a negative du. Okay, I know how to integrate this, so I will switch my x's to u's. My 0 and my square root of 2. Let's see. My 0 will become, oh, that was a 2. It was still there, sorry. My 0, when I put a 0 in, I will get a 0 out. When I put a square root of 2 in here and I square it, it's a 2. So this is 2 over 2, which is 1, and now it's a negative 1. So my 0 remains a 0. My square root of 2 is now a negative 1. Let's go ahead and integrate. I know how to integrate e to the u, so I'm not going to forget my negative. Bring that along. The integration of e to the u is itself, and I will evaluate that from negative 1 to 0. So f of b. When I put in a negative 1, I have a negative. This is e to the negative 1, so if it's okay with you, I'm going to make that an e to the first power in the denominator, minus. My f of b is a negative, and e to the 0 is 1. So my final answer is 1 minus 1 over e. Or if you write it with a common denominator, that would be e minus 1 over e. Either of these are perfectly acceptable. 136. On 136, they say find the area bounded by y equals e to the negative 2x plus 2. Let me check that. Make sure I wrote that right. I did. Y equals 0. That is the x-axis. And x equals 0. And x equals 2. So when they said find the area between this function and bounded by the x-axis between these x's, we know to integrate. We are going to integrate from 0 to 2, e to the negative 2x plus 2 dx. I am going to make my u, the inside function, negative 2x. And I am going to make my du then a negative 2 dx. Okay. I do not see a negative 2 here, so I will multiply by a negative 1/2 or divide by 2. So sorry, I kind of squished it in there. See if I can do that better. Okay, let's separate this a little bit. There we go. Okay, now we're going to have to do this one a little different. There's a couple ways to go, okay? Because I did a u substitution here, but I don't need one here. So these x's would need to be u's, but these x's would stay the same. So if it's okay with you, here's what I'm going to do. I could integrate with the u's and put the x's back in, but I always choose not to do that. So here's what we're going to do. Okay, a little bigger. Here we go. I am going to do my substitution here. My u is a negative 2x, so this is e to the u. And then a dx would be a negative 1/2 du. Okay, I'll come back to here. Plus, I am going to integrate, because I can do it separately, from 0 to 2 of 2 dx. Okay, so what I actually did was split up the integration, where here I have a u substitution, and here I just didn't need it. Okay, now that I know how to integrate this, I am going to switch these u's, these x's to u's. This is fine. I'm going to keep this. Okay. So get my little chart here, x's to u's. I had a 0 and a 2. And when I put a 0 in, I get a 0 out. When I put a 2 in, I get a -4. So my integral where I switched to u's would be 0 and -4. So I will integrate here and integrate here and get those together. All right, so -1/2. The integration of e to the u is e to the u, and I will evaluate that from 0 to 4. Plus the integration of 2 is 2x from 0 to 2. I'm going to do an f of b minus an f of a for both. Here we go. And I'll put the plus sign in between. Okay, here we go. I'm going to put this one in. That would be, oh, forgot my negative. There we go. Okay, -1/2. This is e to the -4. So I'm going to write that as e to the +4 in the denominator, minus, when I put a 0 in, that's a -1/2 times 1, which is a -1/2. I'm at the plus. Here we go, f of b minus f of a here. That would be 4 minus 0, which I don't need. Here we go. My final answer. I have 4 plus 1/2, which is 4.5, or 9/2, minus 1/2 e to the 4th. There we go. They may have gotten a common denominator, but I think we're good here. There we go. Have a great day. Hope this helps you.